Namaskar Mitrano. In this video we will see behavior of the AC through pure capacitor. Again we have given the voltage V is equal to Vm sin omega t. Current I will start flowing in a pure capacitive circuit, or C is the pure capacitor. So first of all we have to find relation between V and I, or what is the behavior of the current in pure capacitive circuit when we apply the voltage. You know that the charge on the capacitor is given by Q is equal to C, that is capacitance into voltage, and current is given by dq by dt. What is Q here? d dt of C into V. So C is constant, I will take it out, and d dt of what? Vm sin omega t. Again C into Vm, what will happen? It is constant, I will take like this, and derivation of sin omega t will be cos of omega t, and this omega will come out, so this will become omega c Vm cos omega t. Now again here the requirement is that current should be in standard sine waveform. So we have to write current as omega c Vm sin omega t plus pi by 2, as this is positive cos omega t. In inductive case we are having minus cos omega t, that's why we have written minus pi by 2. Here it is a positive, so I will write plus pi by 2. Now this will be maximum when sin omega t plus pi by 2 turns to be 1, and that maximum value is written as Im is equal to Wc or omega c into Vm, where this omega c, or you can write 1 upon omega c. So this 1 upon omega c is nothing but capacitive reactance. Okay, it is opposition to the current. Okay, 2 pi fc, or impedance of this pure capacitive circuit, and therefore you can write I is equal to Im sin omega t plus pi by 2. So again compare this current equation with voltage equation. You are finding plus pi by 2 is a phase difference. So phase difference is phi pi by 2, and therefore cos phi is equal to 0. This is also a zero power factor circuit. Now if I plot the waveforms for this, my voltage waveform will be reference waveform, and current waveform must be leading by 90. So current will start before the voltage, that is 90 degree before the voltage. So current is leading behind the voltage. Current is leading the voltage by 90 degree. Okay. So phase difference is pi by 2 or 90 degree. Again here I can prove that power consumed by pure capacitive circuit is 0 by graphically, as well as we can prove by using the equation. So first I write here P is equal to Vi cos phi. As my cos phi is 0, my total power is 0. Or here also I can show graphically, or by using the waveforms, positive positive, so positive power, positive negative, negative power, negative negative will be positive power, again positive negative will be negative power. So power is fluctuating between the capacitor and source. It will never consumes the power, it is just storing it for certain duration. And mathematically again same expression is there. Instantaneous power is equal to V into I, that is Vm sin omega t into Im sin omega t plus pi by 2. And if you want to find P average, we have to integrate from 0 to 2 pi, taking base as 2 pi, to to P d omega t. By solving this mathematically, this power will be 0. So this is for pure capacitor. We can draw the phasor diagram over here. For phasor diagram, my voltage will be reference and current will be 90-degree leading. So current is ahead of voltage by 90-degree. So that's all for all fundamental circuits. In next video, we will solve simple numerical based on fundamental circuits. Thank you.